No audio, madam.
Good evening, everyone. So we have successfully reached our day 5 of FDP. As we all know, our faculty development program is sponsored by AICT Training and Learning Academy. And today we'll be having our 9th session. As we all know, our area is artificial intelligence and data science. And the title of our FDP is Emerging Trends and Applications in AI and Data Science. And today we have a very special resource person with us, Ms. Aisha Nihala ma'am. She is a software engineer from Zoytech. And in order to have a very brief introduction about her, I would like to say that she is a data science professional with over 10 years of experience in data-driven solutions to complex business challenges. And her expertise also spans across various fields like machine learning, statistical modeling, predictive analysis, and also in big data technologies. She also has a hands-on experience in Python, SQL, and other cloud platforms as well. Now, over the years, she has successfully led so many end-to-end data projects, from data engineering and model developments to deployment and business integration as well. And she has delivered measurable impact across industries such as finance, healthcare, e-commerce, etc. And she's also very passionate about transforming raw data into actionable insights as well. Now, it is indeed a very great opportunity for us to have us here with us. Now, she will be talking to us today for our session 9. She will be talking to us on advanced AI and specialized techniques, especially focusing on ANN, artificial neural networks. So I hope we all can have a very good session. I hope that all the participants will be diligent, they will be attentive, and I hope that we can have a fruitful session. And for the session, I invite ma'am on behalf of our college, MES MK Mackar Pillay College, and on behalf of all the coordinators and faculties behind this program. So I invite ma'am for the session. Ma'am, can you hear me?
Yeah. Hi all. First of all, thank you, Ms. to give me such a wonderful opportunity. Thank you so much. Today we are looking, today's section is Advanced AI and Specialized Technique in AI. Okay, so let's move to our section, special Advanced in AI and Specialized Techniques in AI. So let's move on. Okay. So today we are discussing about what is artificial neural networks or what is ANN. ANN simply is a cornerstone of modern artificial intelligence. So ANN is our computational model inspired by human brain. So ANN is inspired by the human brain and designed to reclaim its ability to process information, recognize pattern, and adapt through experience. They represent a subset of machine learning and form the backbone of deep learning. Unlike traditional programming, where exhibit interactions are coded line by line. But in ANN, learns directly from examples and data, building internal representation that allow them to classify, predict, and make decisions. Okay, so unlike other traditional programming language, here we don't need to code it line by line. ANL learns directly from the examples and data, building internal representation, and then that allows them to classify, predict, and make decision. Okay, so this data-driven learning is precisely what makes ANS so powerful in tracking complex high-dimensional problems where rule-based system fails. So ANN is inspired in the human brain. It's a subset of It's a subset of machine learning and deep learning, learns from data from examples and experience for classification, prediction, and decision making. It's an application across multiple domains. This is the basic introduction for ANN. Okay. Next, we already talked about artificial neural networks. Our ANN is inspired by the human brain. So there is a connection between biological and or artificial neural. So next we're looking for what is the difference or the similarity between biological versus and artificial neural. In biological neurons, they comprise three sections or three parts: dendrites, soma, and axon. These are the neurons in these are the neurons in biologically. So, in dendrites, which the performance in dendrites is channels that receive signals. Dendrites are the channels that receive the signals. Okay, then Soma want to do integrate the signals. They receive signals that integrate. Soma will integrate the signals. Then what happen in Azon? Azon will transmit the output to other neurons. Okay, so these are the biological neurons, dendrites, soma, and axon. So dendrites will receive the signals, the dendrites channels that receive the signals, and soma will integrate the signal, and axon will transmit the output to the other neurons. So these are the biological neurons. Then when we move to the artificial neurons, these artificial neurons mimics this process mathematically. Oh, so we look how these process do in mathematically. Okay, so in artificial neural networks, they have input, weight, bias or anti-bias, activation function, outputs, and weighted summation plus non-linear activation function. These are the functions or these are the techniques used in artificial neural networks. Input, weights, bias, activation function, output, weighted summation plus non-linear activation function. Okay. So next we move to what is ANN architecture. ANN architecture, there are three type of layers in ANN architecture. First layer is input layer, then second layer is hidden layer, and third layer is output layer. In ANN architecture, they are training the data by two method, that is forward propagation method and backward propagation method. Okay, so in ANN architecture, there are three type of layers: input layers, output layers, and hidden layers. The training data by two process: forward propagation and backward propagation. This is the simple ANN architecture. Okay. So we go through each and every layers in detail. Okay. So input layer. This is input layer. This is the okay. These are the input. These are the data that received. These are the data are received from our data. These are the raw data. Okay. So in input layers, they receive the raw data or extract the features. Here we receive the raw data. Okay. The next layer is hidden layer. Transfer the input through weighted summation and non-linear activating, progressively extracting deeper representation. So the input data, like raw data, will pass to the hidden layer with a weight value and a bias value. Okay, so here we receive that raw data. The input layer will transmit the raw data into hidden layer with a bias and a weight value. Okay, so here we use activation function. So what do you mean by activation function? Activation function is a mathematical function applied to the weighted sum inputs plus bias in a new row to decide whether it should be activated or that we want to pass the information forward, or we want to decide if you want to pass the information to the next layer. That is activation function. Okay, so here we'll apply the activation function in hidden layer. Then the activation function will decide whether the neuro that received from input layer is passed to the output layer. Okay, so that is called the activation function. So that happen in hidden layer. The output layer will be the generate the final destination, or sorry, final decision, classification, or the prediction. So these are the layers and these are the performance that happen in each
Hello,
and
ma'am.
every layer. Okay.
Ma'am, can you hear me?
Hello.
Hello, ma'am, can you hear me?
Yeah. Tell me.
Ma'am, in the chat, somebody is saying that if you could change the presentation in the slideshow, it would be better. There would be better visibility. They can see properly.
Okay.
So if you can set it to a slideshow, perhaps I think they are not able to see it properly. That's why they're asking.
Oh,
Oh,
okay.
okay, ma'am. Thank you. Thank you. You can continue. Thank you. Okay.
One second.
Sarvation, can you please mute yourself? I think your mic is on. Sarvation, please mute yourself.
Just a minute.
Okay, ma'am. Okay, take your time. It's okay.
Okay, let's continue. Hello, can you hear me? Hello.
Yes, ma'am. You're
Yes, yes,
perfectly
yes.
audible. Yes, ma'am.
Oh, okay, okay. Sorry for interruption. Sorry. Okay. So these are the layers that we use it in ANN. So input layers which receive the raw data or extract the features. Then the input layer pass the data into hidden layer, transfer input through a weighted summation and non-linear activation, progressively extracting deeper representation. So next layer is output layer. Output layer generate the final decision, classification or prediction. So these are the layers we use it in artificial neural networks. Okay. So we already discussed about what is activation function. So activation function simply is a mathematical function with the input summation of input plus bias, which decide whether the neuron is activated or not. Okay, so these are the these are the layers in ANN. So next we talk about two method, or there are two method by training the data: forward propagation and backward propagation. Forward propagation mainly the flow is that from input layer to hidden layer, then hidden layer to output layer. This is the flow of a forward propagation. So forward propagation process of passing the input data through the ANN to get an output data. So forward propagation goes through the input data to get an output data. That is forward propagation. So there are some steps in forward propagation. Step one is features are fed into the input layers. Here the features are fed, and then each hidden neuron consists of bias, weight, and inputs. Each hidden neurons, these are the neurons. These hidden neurons consist of weights, bias, and inputs. Okay. So next layer, what happened? Next layer is apply the activation function to the each and every neurons. Okay, in hidden layer, each and every neurons we apply the activation function. So next will happen will next the neurons or the data will passes to the output layer until reaching the final output layer. So this is the process of forward propagation. So first feed input data from input layers, then next comes to the hidden layer, apply activation function, then next will come to the output layer. Okay, so this is the forward propagation. So from input to hidden and hidden to output, this is the flow of forward propagation. Then backward is the backward flow, which means output to hidden and hidden to input. This is the flow that happened in backward propagation. In backward propagation, the process of adjusting the weight and bias to minimize the errors. So in backward propagation, what happened? They are adjusting the weight and bias in each and every neurons for minimizing the errors. Okay, so compute the loss between predicted output and target output. How they minimize the errors? By calculating the difference between actual value and predicted value. Okay, that's way they compute the loss. Okay, use gradient descent to calculate derivative of the loss with respect to each weight. Propagate the errors forward from output layer, hidden layer, and input layer. So this is the flow in backward propagation from output layer and then input hidden layer and then input layer. So this is the architecture that we use in ANN. So in symbol, there are three type of layers in ANN: input layer, hidden layer, and output layer. There are two methods while training the data is forward propagation and backward propagation. Okay, it's clear? Hello? Hello?
Yes, ma'am, you're audible.
Okay. Next, we move to in detail and type of activation functions. Okay. So activation functions we already discussed is the mathematical functions that apply to the weighted sum of input plus bias in neuron to decide whether it should be activated or not. Okay. So there are different type of activation functions we use it in deep learning. So first functions are sigmoid function. Sigmoid function maps output between 0 and 1, often in binary classification, uh, offered in binary classification for probability. So sigmoid is maps to 0 to 1, the value between 0 to 1. It's used for the binary classification data. Okay. Next activation function is tanh. Tanh is output between -1 and 1. That is 0 grid providing stronger gradient than sigmoid. When compared to the sigmoid, it's there's very strong and gradient. Okay. Then next commonly used activation function is ReLU. ReLU activation function is rectified. The full form of ReLU is a rectified linear unit. This is the full form of ReLU. It is a common activation function in deep learning, and also it's the default activation function in deep learning. Okay. Next function is softmax activation function. Softmax activation function is used for multi-classes probability logic into probability for multi-classification tasks. Okay, so these are the four type of commonly used four type of activation function: sigmoid, tanh, ReLU, and softmax. Okay. So there are different type of neural networks depend on their data or depend on the data. We are different type of neural networks. So neural networks, first we're looking for what is CNN. CNN, full form of CNN is convolutional neural networks. Convolutional neural networks is simply for visualized for images and visions. Here the data will be images or images and vision data. Okay, so if you want to if you want to use a CNN, the data must be in images or vision data. Okay, so CNN is used for capture special hierarchies in data, making them ideal for image recognition, video analysis, and computer visions. So these are the examples that we use it in CNN. The most common example we can choose is CNN as image recognition. Okay, then RNN. RNN, full form of RNN is recurrent neural network, designed for sequential or temporal data such as speech, text, and financial time series. Advances variants like LSTM and GRU make long-term dependencies challenges. So, recurrent neural network is designed for sequential or temporal data such as speech, text, and financial time series. Okay, next is GANs. GAN is Generative Adversarial Network, consists of a generator and discriminator competing in a min-max game, providing high realistic synthesis data such as images, videos, and even molecular structures. So these are the architecture demonstrate how the basic ANN model adapts and involves to suit domain specified requirements. So we can choose on our requirements which data, which model or which type of neural networks we can use. If you use the data in image data, you can use CNN. Or if you want, if your data in text data or a speech data, so you can use RNN. That also in your requirement basis, we can choose any of the neural networks. So these are the neural types of neural networks. Okay. Okay. Next, we move to advantages of ANN. Hello, hello. Can you hear me? It's all
Yes, ma'am. Yes, ma'am. We can hear you. Ma'am?
advantages of ANN. The advantage, the power of ANN lies in the ability to do learn a model complex, no relation, no linear learn directly in introduction. We said that ANN is learned directly from the raw data, is it? So in learn directly from raw data, reducing the needs for manual feature and engineering. So that is the main advantage in ANN. It's in ANN or in any neural networks, it's learned from directly from the experience or directly from the raw data. That is the main advantage in any ANN or any neural networks. Okay. Next is adapt across diverse domains from healthcare to robotics. Achieve the state of the art performance were trained on large data set. In ANN, the data will train on the model will train on the large data set. Okay. Work across diverse application domains. We can apply ANN in the multi-purpose domains or multi-purpose application domains. Okay, so these are the advantages in ANN. Is it clear? Hello. Okay. There is a disadvantage
Hello, ma'am.
of ANN. We call it large data set. That is, it's an advantage and it's also an disadvantage. Require large data set. Okay, so while require that data set, it's take more computational cost or computational power. Training deep network is resource. Okay, so requiring large data set, it's a disadvantage of ANN. Okay. Next disadvantage is interpretability. Often functions like as black box, raising concern about explanative. Then next is overfitting. Overfitting is a process of the model is overfitting or the accuracy is overfitting. That is a process of overfitting. Prone to memorize the instant of generalizing with this model. The overfitting is process of generalizing with a small data set. Okay, so overfitting is the main disadvantage of any neural networks. When a overfitting is happen, it causes defect in prediction also. So the overfitting is the main disadvantage in ANN or any other neural networks. Okay. Next is hyperparameter toning. Toning is complex. Hyperparameter is the performance is highly dependent on the careful toning. So hyperparameter sensitivity is performance in is highly dependent on careful toning. So these are the challenges from the core of ongoing AI research, particularly in explainability, efficiency, and ethical developments. So these are the advantage in disadvantage. The main disadvantage is risk of overfitting. When the overfitting is happen, it causes the defect on the prediction also. So always we keep on mind good fitting make the model in good fit. Okay, then the prediction will also in good form. Okay, so these are the disadvantages of ANN. Okay, next we move to application of ANN. Application of ANN, we all already discussed that in ANN we can use in multiple domains. Okay, we can use in healthcare, finance, or any like natural language preprocessing like NLP. We can use in multiple domains. So, ANN are revolutionary multiple interests in healthcare, finance, natural language preprocessing, computer vision, automation system, like anywhere we can use ANN. Okay. In healthcare, what is the purpose of in ANN in healthcare is disease diagnosis, drug discovery, medical imaging. Uh, methods that we use in healthcare sections. Then next is finance. Finance is fraud detection. We can use ANN for detecting the fraud, or we can use ANN for simple example, real time example. We can say that email spam or not. We can use ANN to detect a email spam or not. So in finance, we can use fraud detection, we can use ANN, trading, etc. Then NLP is a natural language preprocessing. NLP used for pre-processing natural languages like English, Hindi, like that. So in natural language preprocessing, the language translation, sentimental analysis, and intelligent chatbots. As we all know, ChatGPT, is it? We use ChatGPT. So ChatGPT is an example of NLP. ChatGPT is used by NLP. Here we translate here. Our language is translation or sentiment analysis, and we question anything and the ChatGPT answer it. It's an best example of NLP. Okay, next is computer vision. Computer vision is a we can use computer vision for face recognition, object detection. If you want to detect, the best example of computer vision, attendance-based system. Attendance-based system in every office, we can use attendance-based system. When the camera on, live camera on, they automatically detect the person in front of the camera and make the employee ID present. Okay, so at the face recognition is the best example in computer vision, object detection, and image restoration. store our image into a particular die by using computer vision. So, computer vision is also an best example in application of ANN. Okay. So these are the applications of ANN: healthcare, finance, NLP, and image recognition, and robotics, autonomous vehicles. Okay. So autonomous systems are the robotics or self-driving cars. That are called autonomous vehicles. Is it clear? Sorry. Hello. 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 Okay.
Hear me, it is clear. Hello,
Oh,
ma'am.
okay, sure. Okay, okay, okay.
Hello, ma'am. Am I not?
Hello.
It is.
Can I continue? Sorry, your voice are breaking. Can I continue? Oh, okay. Next topic is real world use cases. These are the real world use cases. We goes to through day-to-day life, like Google Translator. Okay, Google Translator is all we know, that language translation. Language translation, we can translate any language to any language, from our mother language to any other language. Is it? So, Google Translation is the best example of NLP. Here using NLP for translating one language to another language. Okay. Next is Netflix. Netflix is recommendation. From Netflix, what happened? Here, the model are training by previous data. Here, they are collecting the previous data and training them from the previous data to predict the futures data. So here that recommendation is basically by storing the previous data and training in using deep learning, machine learning models, and predict the futures data. That is recommendation. The autopilot uses CNN and RNNs for real-time perception and navigation. Next is voice assistance. Alexa and Siri rely on deep learning for the speech recognition and natural language understanding. Next is Email, I already dealt in fraud detection, email spam detection. So, by using ANN, we can detect a mail is spam or not. By using ANN, we can detect a spam or not. So these are the real world use case in ANN: Google Translator, Netflix, Tesla, Autopilot, Siri, and Alexa, and Gmail. These are the real world use cases. Then there are some tools and libraries we use at AML. For implementation, we are rely on powerful ecosystem. So first we looking for what is TensorFlow and Keras. TensorFlow and Scalars are a scalable framework with the extensive industry adoption. It's a framework. Both the TensorFlow and Keras is a framework with the extensive industry adoption. Okay. Then PyTorch is a highly flexible framework. PyTorch is a highly flexible framework. Scikit-learn used for smaller scale ANN application. Scikit-learn, which is used for smaller ANN application and for ML tasks, machine learning tasks. Then we can choose a cloud platform like Google Colab and AWS uh, Maker. So these are the cloud platform we use for Google Colab and AWS. GPU acceleration for deep learning. So these are the tools and libraries we used in neural networks. TensorFlow, Keras, and PyTorch. These are the frameworks that we used uh, in ANN. So scikit-learn is used for smaller scale ANN application. We can use cloud platforms like Google Colab, AWS, GPU acceleration for deep learning. So these are the tools and libraries we use in ANN. Okay. Next, we looking for future scope of ANN. So first is Edge AI and IoT integration. Edge AI and IoT integration is running neural networks on low power embedded devices. Uh, the example of Edge AI and IoT integration is sensors. Okay, we can use sensors for detecting a particular task or a particular performance. So, IoT integration is based on this example for IoT integration is sensors. We can detect or we can perform a particular task by using a sensor. Okay. Next is brain-computer interfaces. Brain-computer interfaces enable communication between human and machines. Here, they do the interacting or the process communication between brain and human. Okay, the robotics is the best example for brain-computer interface. Next is advanced generating model. Advanced generating model creating relative contents across the domains. In domains, they are creating realistic contents. Okay, the symbolic AI, combining the reasoning power of symbolic AI with the neural learning. Okay, then expandable and responsible AI, addressing transparency, fairness, and ethics in AI development. These trends indicate that ANNs are not just powerful today, but are set to transform future human technology interaction. So these are the future scopes of the ANNs, Edge AI and IoT integration, brain-computer interface, advanced generating model, symbolic AI, explainable and responsible AI. So these are the features, scope of AN. So these are here is a summary of ANN. So ANN is a brain-inspired computational model of modern AI and deep learning, versatile application process multiple domain. Challenges include interpretability and efficiency. Future research is vibrant and involving. So these are the summary of ANN. So, so let's conclude this section. Artificial neural networks represent a powerful pyramid in artificial intelligence. They excel at learning complex patterns, enabling breakthrough across the science, technology, and society. Yet they also raise fundamental questions about integrity, ethics, and sustainability. As researchers, our challenges is not only push the boundaries of ANN performance, but also ensure that development is responsibly transparent and inclusive. So that is the for today section. So is if you have questions based on this section? Hello.
Participants, please ask if you have any queries or doubts. Are there any queries? Ma'am, there is a question in the chat box. Do you want me to read it out?
Yeah.
The question is, I think there is some spelling mistake in that. Sorry, no. It was my mistake. The question is, can ANN handle imbalanced data set? Can
Yes,
ANN?
KNN can handle imbalanced data sets, but not automatically. We can do some training during the training section. We can apply some strategies. Then only we can use imbalanced data set.
Okay, ma'am. Are there any other questions, guys? Ma'am, there is one more. I will read it out. How ANN is different from CNN and other ML models?
Hello.
Ma'am, do you want me to
Hello.
repeat the question? Do you want me to repeat the question, ma'am?
Yes, yes.
Okay, ma'am. I'll read it out again. The question is from Sangeeta. How ANN is different from CNN and other ML models?
Okay. ANN basically there are input NN in ANN, the data is the main difference between ANN and CNN is that in ANN, we use it, the data, it's a numeric data or a continuous value data. Okay, but in CNN, we use image data sets. Okay, so that is the main difference between ANN and CNN. The networks or the layers in used in ANN is that input layer, hidden layer, and output layer. In CNN, we use another layer called convolutional neural network layer. So that it's also a difference between CNN and ANN. So next is other machine learning models. We can choose decision tree machine learning model. In decision tree machine learning models, you don't use any neural networks, okay, or any layers in machine learning model. But in deep learning models, we use neural networks or layers. That is the major difference between ML model and deep learning model. In ML model, we do not use any neural networks, but in deep learning model, we use neural networks or layers. That is the major difference between CNN and ML models. Okay.
Okay, ma'am. So, guys, are there any other doubts? Yes, ma'am. There is one more from Vipul. I will read out. What is transform learning?
Okay. Transfer learning is using a pre-trained model on one task and adapting it into a new task. It's a transfer learning is a pre-trained model. It's training and model training is already happened. So we use the pre-trained model to perform a particular task. That is called transfer learning. It's a pre-trained model data, pre-trained models.
Okay, ma'am. Okay. Are there any other doubts from anyone? Kavita, you unmuted yourself. Do you have any doubt? I hope not. Let me check. Yes. Okay, ma'am. There are no further doubts. So,
Okay.
okay. So, ma'am, we are coming to the end of our session, right?
Yeah.
Okay, ma'am. So, I want to ask if any other participants have any feedbacks. Do they have anything to say about the session? Okay, ma'am. So everybody is appreciating. They are showing so much love in the chat box. Ma'am, I'll have to say that the session was very interesting. You talked about ANN in a very unique way. You started talking about it, you defined it, and then you explained forward propagation and backward propagation. You also talked about different activation functions and various types of neural networks. And then you came to the conclusion by explaining the advantages and various applications of ANN. It was indeed a very coherent and comprehensive session, I must say. Thank you so much, ma'am. On behalf of my entire college and the coordinators of FDP and the faculties, I extend my sincere gratitude for being a resource person. Thank you so much, ma'am, once again.
Thank you everyone for your attention. Thank you so much. Thank you.
Thank you, ma'am. Thank you. Okay, ma'am, you can take a break. You can have some rest. So, guys, I would like to remind the participants that the link of the feedback form has been posted in the chat box. So please access the link and fill out the forms so that we can mark your attendance. And I would also like to say that our next session will only begin at 7:30. So please be back by then.
Good evening, dear participants. Welcome back. So let's get started now. We truly appreciate your patience during the break. Hope you all are feeling refreshed and ready to continue. So let's start now. So we are moving to the session number 10 on the topic natural language processing. To speak on this topic, we are delighted to have with us Ms. Tirtha Sajith. She is a data scientist in Futura Lab Technologies. I believe she is a familiar face for us. Tirtha Sajith is a data science professional and trainer with a background in mathematics and data science, with expertise in Python, machine learning, deep learning, and data analytic tools. Also, she holds a NACTET certification in data science, and she has hands-on experience in real-world projects and strong passion for mentoring students and professionals. We truly believe that we got an apt resource person to talk here. On behalf of MASMK Mackar Pillay College, Edathala, I welcome Tirtha ma'am to begin the session. I believe this will be a beneficial experience for you all. Once again, I invite Tirtha ma'am to start the session. Over to you, ma'am.
Thank you, ma'am.
Okay, you can start, ma'am.
Good evening, everyone. I am Pita Sajid, working as a data scientist at Futura Labs and expertise in data science and artificial intelligence. Now, let's begin the session. Okay, we will start with an introduction to NLP, then explore its key components and process, and finally wrap up with a conclusion. First is introduction. In the introduction, we will discuss what is NLP, how it works for and machines, and why it's important. Natural language processing or NLP is the branch of artificial intelligence that focus on helping computers understand and work with the human language. I think you can hear a presentation, right? Hello. Hello.
Yes, ma'am, we can see the presentation.
Okay. Okay. Uh, it's act as a bridge between the way we human communicate. It's text or speech, and the way machines understand information, which is usually in numbers and code. With NLP, the computers can read, listen, interpret meaning, and even respond in a way that feels natural to us. Employees you might already use include Google Translate, Siri, Alexa, and chatbots. Google Translate is translate text or speech from one language to another, use neural machine translation, a type of deep learning model, and analyzes entire sentences, not just by word. It capturing the context and grammar, continuously improve the user feedback and national multilingual corpora. Then also, no other chatbot is Siri. Siri is familiar for us. It is a voice assistant that understands and responds to natural language commands, and it converts spoken language into text. It is automatically speech recognition. Then use natural language understanding to interpret content and gives response using NLG. That is natural language generation. Then also familiar is Alexa. Alexa is introduced by Amazon. It is also similar to Siri but integrated with smart home system and third-party apps. It uses wake word detection, speech recognition, and intent understanding, adapts user to performance and context over time. Then what is NLP? NLP is process information contained in natural language text. It also known as computational linguistics, human language technology, and natural language engineering. NLP for machines. Analyze and understand and generate human languages just like human do. Then applying computational techniques to language domain. Make computers to learn our language rather than we learn, to explain linguistics theories, to use the theories to build systems that can be social use. Uh, when we talk about NLP for machines, we can developing system that can process human languages in the same we do by understanding meaning, recognizing text, and even generating response. Traditionally, people had to learn a computer's language like programming syntax to communicate with. NLP reversed that idea. Now we train machines to learn our language so the interaction feels natural. This opens to huge of application. For example, uh, assistive technology for the visual impaired, when where text can be read aloud or voice commands can control devices. Then language learning apps like Duolingo that uses NLP to understand and respond to what learners say or type. Then speech to text system that turns spoken language into written form for documentation accessibility. The main NLP for machines, the aim is to make machines analyze, understand, and generate human language like human do, rather than humans learning a computer language. For example, programming. We make computers learn our language. Then application include building system for social use, such as assistive technology for the visually impaired or language learning apps. Then next one is why NLP? Why NLP means a hallmark of human intelligence, that is our ability to communicate in language. The hallmark of human intelligence means our ability to communicate in language. Then text is the largest repository of human knowledge is growing quickly. That is, text is equal to a largest repository of knowledge, right? Books, articles, and websites like that. Then computer programs that understood text for speed. The computers that can text or speech can automate tasks like search, translation, and summarization. For example, voice assistants. We already told Siri like Alexa Siri. Voice assistants using NLP to interpret commands. Then next we discussed about the components and process. It contains components of NLP, steps of NLP, and techniques and method. The first one is components of NLP. The components of NLP mainly divided into two key parts. The components of NLP are mainly divided into two key parts: natural language understanding and natural language generation. In natural language understanding, taking some spoken or typed sentence and working out that means. That is, this is the part where a computer take what you say or what you type and interprets this meaning. It focuses on breaking down human language. Breaking, sorry, it focuses on breaking down human language into something a machine can work with. For example, if you say, book me a flight to Delhi. If you say, for example, that is an example. If you say, book me a flight to Delhi, and then you help the system understand the action you want. Okay, if you say, book me a flight to Delhi, NLU help the system understand the action you want. Booking a flight and key detail, the destination is Delhi. It involves identifying intent and extracting import information from your word. That is an example for NLU. Okay, then next one is natural language generation. Natural language generation means taking some formal representation of what you want to say and working out a way to express it in a natural language. Then that is, once a system has processed and understand the information, NLG does the opposite of NLU. It takes structured data and turns into sentences we can easily read or hear. That is, natural language generation is once a system has processed and understand the information, NLG does the opposite of NLU. It takes structured data and turns it into sentences we can easily read or hear. For example, if a weather system has stored data like temperature. Normally we store a temperature like 30 degree or any other values in degree Celsius, and condition is sunny. Then NLG into a natural sentence like today will be sunny with a high of 30 degrees Celsius. Okay, that is if a weather or for example, if you store a temperature like 30 degrees Celsius and the condition is sunny, the energy convert into a natural sentence like today will be a sunny with a high of 30 degrees Celsius. So NLU is about understanding what we say. Okay, then while NLG is about speaking back in human friendly way. Okay. Hello? Hello?
Yes, ma'am, you continue.
Okay. NLU is about understanding what we say, while NL is about speaking back in human-friendly way. Then we discussed about steps of NLP. The first one is lexical analysis. Then next is syntactic analysis and semantic analysis, discourse integration, and last one is pragmatic analysis. The first one is lexical analysis. The process of NLP involves several important steps, each adding a layer of understanding the text of speech. The first one is lexical analysis. It is the process of converting sequence of characters in text into a sequence of tokens like words, punctuation, etc. And it is one of the earliest steps in processing natural language and forms the foundation for more advanced tasks like parsing, semantic analysis, or machine translation. Example, breaking text into tokens. Those tokens could be words, punctuations, or other meaningful units. Then removing irrelevant characters. Remove unwanted characters such as space, white spaces, extra punctuation, etc. Or common words. Categorizing tokens means identifying part of speech, named entities, etc. That is, in lexical analysis, it is the first step. The lexical analysis is the first step where we break down the text into smaller unit called tokens. Those can be words, punctuations, or symbols. We also remove unnecessary characters. Like extra spaces or redundant punctuations. At this stage, we can also label tokens with useful information like their part of speech. Part of speech means noun, verb, etc. Or whether they are named entities. Named entities means, for example, a person, a place, or organization. For example, we write, I love India. Then in lexical analysis, the sentence is tokens. The sentence is split into tokens like I, comma, love, comma, India. Okay. I will show some examples of this process. The next one is syntactic analysis. Syntactic analysis means it is also a parsing. It is the process of analyzing the structure of sentence according to the rule of grammar. It determines how words related to each other and whether the sentence is grammatically correct. In syntactic analysis, it is also known as a parsing, the process of analyzing the structure of sentence according to the rule of grammar. It determines how words related to each other and whether the sentence is grammatically correct. In syntactic analysis, also called as parsing, it is the step where we look at a sentence structure according to the grammar rule. It is about figuring word sentence. It is about figuring out how the words sentence are connected, what role each word plays, and whether the sentence is grammatically correct. The steps are to identify the sentence structure, phrases, clauses, and dependencies, to check for grammatical correctness, to build parse trees or dependency graphs, to support downstream tasks like machine translation, question answering, semantic analysis, and etc. In this step, we identify sentence structure. sentence structure like phrases, clauses, and word dependencies. Check if the sentence follows grammar rules. Build visual representation such as parse trees. Parse tree means constituency parse tree. It shows how words group together into phrases, like noun phrases, verb phrases, etc., according to grammar rules. It's a hierarchical starting from the whole sentence and breaking. Or dependency graph. The other one is dependency graph. The map out of those relationship. Dependency graph means focus on relationship between words. It focus on relationship between words, which is word depends on which. Show grammatical role. Grammatical role means subject, object, modifier, etc. In syntactic analysis is essential because it prepares the data for other NLP tasks like machine translation, question answering, or semantic analysis. For example, before translating a sentence to another language, the system must which word is the subject, which is the verb, and how they relate. Okay, this is semantic analysis. And the next one is discourse integration. It is the processing, natural language processing of understanding how individual sentences related to another in a larger context. For example, paragraph or conversion. That is, uh, excuse me, please wait for a 1 minute. Hello, hello, hello,
Yes,
Shikha.
ma'am. Yes, ma'am.
Can you wait for a 1 minute?
Yeah, yeah, sure, ma'am. You take your time.
Hello. Okay, okay, we can continue. Hello.
Okay, ma'am. Okay, ma'am. You continue.
Okay. Discourse integration. In discourse integration, it is the process in natural language processing of understanding how individual sentences related to one another in larger context. For example, a paragraph or conversion. It is about connecting individual sentences to understand the bigger picture, whether it is in a paragraph, a conversation, or an entire document. It goes beyond looking sentence in isolation and focuses on how they related to one another. Understand the examples of the steps of discourse integration is understand context, track entities and their roles across sentences, resolve anaphora or co-reference. For example, interpret discourse relation. For example, cause, effect, contrast, elaboration. Build a coherent semantic model over multiple sentences or utterances. Understanding context means knowing what's already being said to interpret new sentences correctly. Track entities. Track entities means keeping track of people's objects or concepts as they are mentioned. Resolve anaphora or co-reference means figuring out what words like he, it, or this refers to. Interpret discourse relations. Interpret discourse relations means such as cause effect. Cause effect means, for example, is if rained, so the match was cancelled. It is example for a cause effect. Cause effect means, such as example of cause effect is it rained, so the match was cancelled. Contrast. Contrast means he tried, but he failed. Or elaboration means, not means the example of elaboration. She bought a car, a red sport car. Then build a coherent semantic model means creating a connected understanding of meaning in multiple sentences. For example, in John went to the store, he bought milk. The example of discourse integration is in John went to the store, he bought milk. The system must know that he refers to John and that the two sentences together form a meaningful sequence of action. And the last one is pragmatic analysis. The pragmatic analysis is about figuring out what someone really means, not just what the words literally say. It is the process of interpreting what a speaker actually means by their words, taking into account context, intent, and real world knowledge. It goes beyond the literal meaning. Literal meaning is semantics to uncover intent, meaning, implication, and social causes. The steps are speaker's intention, context dependent meaning, implied or indirect communication, politeness, sarcasm, humor, etc. In pragmatic analysis, we look at speaker's intention. Speaker's intention means what the person truly want to communicate. The speaker's intention means what the person truly wants to communicate. Next one is context dependent meaning. Context dependent meaning means the same sentence can uh, mean different things in different situations. Implied or indirect communication means understanding requests, suggestions, or opinions that are not stated directly. Then social cues like uh, politeness, sarcasm, or humor. The example of pragmatic analysis. Uh, if someone at the dinner table says, "Can you pass the salt?" They are not asking if you are physically capable. Sorry, if you are physically capable, they are politely asking you to hand them the salt. Okay. Uh, the example of pragmatic is, can you, if someone at the dinner table says, "Can you pass the salt?" And they are not taking if you are physically capable. They are politely asking you to hand them the result. Similarly, if a friend says, "Wow, you are punctual when you are late." Then we discussed about techniques and methods in natural language processing, input database and training data. System based on automatically learning, the rules can be made more accurate simply by supplying more input data or source to it. However, system based on handwritten rules can only be made more accurate by increasing the complexity of the rules, which is a much more difficult task. Input data, training data, and system accuracy. That is data driven. Data driven system is learning based. That is, the system learn patterns and rules automatically from the data. In data driven systems, the systems learn pattern and rules automatically from data. For example, machine learning, deep learning models. Then how to improve accuracy? And how to improve accuracy is simply provide more input or training data. In data-driven system, if you want to improve accuracy, we simply provide more input or training data. A larger data sets allow the system to better understand patterns and generalize new cases. New cases. For example, a spam mail. For example, a spam email classifier improved as it sees more emails labeled as spam or not spam. The other is rule-based. Rule-based system is handwritten. It is the system rely on explicit rules written by humans. For example, if temperature greater than 30, then turn on fan. It is handwritten or rule-based systems. Then how to improve accuracy? How to improve accuracy means the only the only way is to add more rules or make rules more complex. And this is difficult and time consuming, especially as the problem scales. The example of a rule-based or handwritten system, a medical diagnosis system that depends on hand-coded rules for each symptom combination. An example of a handwritten system is a medical diagnosis system that depends on hand-coded rules for each symptom combination. Hello?
Yes, ma'am.
Okay,
You can continue, ma'am.
okay. Next is text pre-processing technique. Text pre-processing techniques mean the first one is tokenization. Tokenization means splitting. We already taught the tokens. Tokens. What is tokens? The token is split the words into smaller units. That's what tokens. The tokenization is splitting the text into smaller units like words or sentences. Breaking text into smaller units called tokens. The types are word tokenization. The types in tokenization is word tokenization and sentence tokenization. Word tokenization means splits text into word. For example, I love AI. The example sentence is I love AI. This is a single set. Sorry, this is a single sentence. In tokenization, in word tokenization, we split the words into tokens. That means split I love AI. I comma love comma AI. The original sentence, the AI. Then we tokenize the sentence. We get I comma love comma AI. The next one is sentence tokenization. The sentence tokenization means split the text into sentences. Word tokenization means word into split text into word. In sentence tokenization, split text into sentences. For example, I love AI. It is amazing. Then use sentence tokenization. We get I love AI, comma, the other sentence is it is amazing. I wrote I love AI dot it is amazing. There's are two sentences in there's a one sentence separated with the dot, then split the word into tokenization. That is I love AI and it is amazing. The purpose of tokenization is make text manageable for further processing. Purpose for tokenization is make text manageable for further processing. Then next one is stop word removal. Stop word removal means removing frequently used but insignificant words. That is common words or frequent use in words like example is the a at like that. It is a stopword removal is removing common insignificant words that don't carry meaningful information. For example, is, the, and, of. The purpose of stop word removal is reduces noise in the text. The purpose of stop word removal is reduces noise in the text and improve model focus on important word. Okay, the next one is stemming and lemmatization. Stemming and lemmatization means reduces words to their base or root forms. In stemming, cut words to their root by removing suffixes. For example, running tends to run, fishing tends to fish. In lemmatization means convert words to their base form considering meaning. That is, for example, better we can also write good, was, tends to be. The purpose of lemmatization and stemming is standardize words to a common form to reduce redundancy. The purpose of some stemming and lemmatization is standardize words to a common form to reduce redundancy. The next one is pause tagging. Pause tagging means assigning a part of speech to a token. Example, noun, verb, etc. That is, assigns grammatical categories, noun, verb, adjective, etc. to each word. The example of parts of speaking is AI is amazing. And we know that AI is noun and verb is AI noun is or verb is amazing. The purposes of parts of speech tagging is help to understand sentence structures and word relationships. The last one is named entity recognition. Named entity recognition or NER is detecting proper names like people, places, organization. The definition for named entity recognition is detect and classify proper noun is test. For example, people, we can say people name is Albert Einstein, the place is Paris, organization is Google. It is for extracts key information for analysis, search, or knowledge graphs. I will show some examples of test processing level 1. First, we want to import the natural language processing toolkit NLTK. NLTK is tool or framework for NLP. Then first we want to download a FunKit. This is a specific model tokenization model. This is for FunKit is a tokenization model, and WordNet. WordNet means a lexical database for the English. WordNet download for lexical database for English. Then the first one is we already told the first step of NLP is tokenization or test processing is tokenization. The tokenization is the process for splitting a word into individual sentences, and it is used to identify the boundaries between sentences in a given text. First, we want to import the module for tokenization from NLTK.tokenize import word tokenization. word tokenization used for token. The split the words into tokens. I was already give a sentence. Is word equal to glad I met you. This is my sentence. Then I tokenize the sentence. Then we get the output is glad, comma, I, comma, met, comma, you. This is word tokenization. Word tokenization means split the words into tokenization. The next one is sentence tokenized. Sentence tokenized means to split the sentence into tokens. That is, hi, uh, uh, hi, my name is Tilka, and I am doing good. Then sentence tokenize this sentence. When we use sentence tokenization for this sentence, we can see that the output is hi. Hi is one sentence. My name is Tirtha and I am good in other sentence. Okay. Then stemming. The stemming is tool based on a process of removing suffixes from a word to get to the root from which may not be valid word. First, we want to import the functions for stemming. For the stemmer from nltk.stem import for the stemmer. It is used for stemming. Then first we want to initialize the porter stemmer into an object. So PS is equal to porter stemmer. We use an object name PS and assign the porter stemmer. Initialize the porter stemmer into PS. I used a sentences. I used storing and processing data is done by traditional method. The sentence used for stemming is storing and processing data is done by traditional method. Then in every process we first want to do in in stemming, lemmatization or chunking. First we want to split the words into smaller units. The first step of test processing is split the word into smaller units. So first we split this sentence into smaller unit. Use word tokenize. Then here we use a for loop for line by line one by one execution. We use for loop, a sequence of we already know that for loop is for iterating over a sentence. We used to for loop. For loop is used for iterating over a sentence, and I used W in for iteration in words. Our word is storing and processing data is done by traditional method. Then print original word W. Then PS dot stem of W means stem the word. The word stemming. We can see that the original word is storing. Stemmed word is stored. The next one is and. The stemmed word also and processing. We can see that the last suffixes is removed. Then data is data. Is done is done. By is by traditional. We can see that credit and methods is method. The main characteristic of stemming is fast and simple. It is a fast and simple method. May produce non-dictionary stems. The algorithm, we already see that the algorithm for used in stemming is Porter stemmer. Also, we can use snowball stemmer, Lancaster stemmer also. Then the next one is lemmatization. We already saw that lemmatization reduces it into lemma. Lemma means dictionary based form. The lemmatization reduces a word into lemma. The lemma means dictionary based form. It considering the context and part of speech. Okay. First, we want to install a package ONW version 1.4. Here we use word net lemmatization for lemmatizing a sentence. From NLTK.system, import word net lemmatizer. First, we want to initialize the word net lemmatization into an object. We wrote WNL equal to word net lemmatization. Then I given the text is the same text. The storing and processing data is done by traditional the storing and processing data is done by traditional methods. Then we want to tokenize the sentence. Words is equal to word tokenize of text we given text. Then here also we use for loops of one by one execution. For W in words, print original word W, stemmed word WNL dot lemmatize. We can see that storing is storing, and processing is processing, data is data. Data is done, by is by, traditional is traditional, method is method. The main characteristics of lemmatization is more accurate, produces valid dictionary words. It's lower, requires linguistic knowledge. For example, WordNet, Spacey. The main use cases of stemming and lemmatization is which when speed matters more than accuracy. In lemmatization, when understanding context is important. Example, machine translation, question answering also. Then I also give some comparison between word net lemmatizer and stemming. Here I given a word beliefs. Then lemmatized, we can see that the word is belief. In stemming, we can see that belief. The other one is captures. In captures, we use lemmatize. Then also in lemmatization, we can see that it's capture. Stem also capture. Okay. The other one is, we already told that stop word removal. The stop word removal involves filtering out common words. Those common words are known as stop words. Typically include articles, preposition, conjunctions, and other frequently occurring words in a language. Here we used for the package for stop words removal is stop words. We want to download the package stop words. Then we used when we use the function is stop words. The stop word is imported in NLTK from NLTK.corpus import stop words. First, we want to store a set of stop words into a variable. We want to list out a set of English stop words into a variable, that is set of stop words dot words of English. Then given an example sentence, an apple a day keeps diseases at bay. This is a example sentence, a sample sentence. Then first we want to tokenize. First we want to tokenize and tokenize the sentence. Then we use list comprehension. Then we use a list comprehension for filtered sentence. W for W in the word tokens. If W not in stop words, W for word tokens. If W not in stop words, the when we get the output is apple, then we get the output is apple, day, keys, diseases, we. So we can see that here we remove an a at, and this is the stop words in this sentence. In this sentence, the frequent word or stop word is a at. So we remove that tokens into our sentence. Then next one is post tagging. Post tagging means it is the process of categorizing each word in a text into. It is the process of categorizing each word in a text into a particular grammatical category or part of speech, such as noun, verb, adjective, adverb, pronoun, preposition, conjunction, etc. Here we download a package is averaged perceptron tagger. Here we use average perceptron tagger.
Hello, ma'am. Your mic is muted.
Sorry, can you wait for 1 minute?
Yeah, sure, sure.
Hello? Hello?
Yes, ma'am. Yes, ma'am.
Hello?
Yes, ma'am. Can you hear
Hello?
me?
Hello? Hello? Can you hear me?
Yes, ma'am. Yes, ma'am. We can hear you.
Hello?
Hello, ma'am. Tirtha, ma'am. Can you hear me? Hello, ma'am. You are audible.
Okay.
Hello. Yeah. Yes,
Here
ma'am. You can continue.
use pack, the post tagging package is averaged perceptron tagger. Here we use a text, that is text analysis, also referred to as text data mining. It roughly equivalent to text analytics, and it is the process of delivering high quality information from text, and high quality information is typically derived through the devising of patterns and trends through means such as statistical pattern learning. This is an example sentence for part of speech tagging. First, we want to tokenize the text into sentences. First, we want to tokenize the text into sentences. Uh, Here use set tokenize for tokenization, and iterate over each sentence is tokenized. For again tokenize, the first one is tokenize the sentence into words, word tokenize. Then next step is removed stop word. Removed stop words. The next one is NLTK dot post tag is used for perform part of speech tagging. Okay, we can see that the text is NNP. The text is NNP, mining is NN, NN means noun. Then also is RB. RB means adverb, and reference is VBD. VBD means verb in past tense. Some more post tags are you can see here. In sorry, the conclusion of the stemming and lemmatization we can the conclusion for stemming and lemmatization is both stemming and lemmatization are both essential text normalization techniques in uh, natural language process. While stemming is faster and simpler, it often produces crude or incorrect roots forms. On other hand, lemmatization is more accurate more accurate and context aware, producing meaningful base words by considering grammar and dictionary definitions. Use stemming when performance and speed are priorities. Use lemmatization when linguistic accuracy and contextual meaning are important. Uh, in conclusion, for post tags and stop words, both post tag and stop words removal are essential pre-processing steps in natural language processing that serve different but implemented the purposes of tagging post tagging is helps identify helps identify the grammatical role of each word in a sentence. For example, noun, verb, adjective. It enables deeper linguistic analysis such as parsing, named entity recognition, and sentimental analysis, and adds context and structure to robust improve the performances of NLP model. In stopper removal is involving filtering filtering out uh, it involves filtering out common words like the, she, the, and it, like that carry lithic meaning in text analysis, and it helps reduce noise and dimensionality in data set, and it involves efficiency and focuses on meaningful content in tasks like test classification or information retrieval. In summary the summary is use post tagging. Use post tagging when understanding sentence structure and meaning is important. Use stop words. Uh, Use stop words removal to simplify text and focus on informative words. Both are fundamental and cleaning and preparing text data to accurate and efficient for NLP. I also uh, give an example for, I also show an example for named entity recognition. Here is the example for named entity recognition. In named entity recognition, identify and classify named entities such as persons, organization, locations, dates, and more within a text. Here I use a sentence. Here I given a sentence. Google is an American multinational technology company that specializes in related services and products, which include online advertising technologies, search engine, cloud computing, and hardware. It was founded in 1998 by Larry Page and Sergey Brin while they were PhD students at Stanford University in California. This is the sentence for named entity recognition. The first step, we want to tokenize the sentence into tokens, NLTK dot word tokenization. Then we want to do post tag. We want to do part of speech tagging. The next one is chunking. Then the last, we want to use extract all the entity. We want to extract all named entities. That is named entities equal to given a empty list. Then we want to append the named NER into that empty list. Okay, here we use it for tagged training chunked sentence. We here if has atter means returns has atter returns true if and has the given named attribute and false if it does not. If has the is check if the tree has label attribute, then in the leaves of tree, then extract named entity recognition, then extract entity type, then append the sentence, append the named entity into the list. We can see that the Google is NNP, America is NNP, Larry Page also NNP, Sergey is NNP, Brin is NNP, Stanford NNP, University NNP, California NNP. Then bring the entities. We can see that Google is a organization, America, Larry Page is a person, Sergey is a person. Okay. Then we can discuss about future of NLP. First one is human readable NLP is an AI complete problem, meaning it is an hard essay making the hard essay making the hard essay making a machine fully intelligent like human. Solving NLP at this level is like solving the challenges of AI, making computers think and understand like people. Then the future of NLP is strongly tied to the growth of artificial intelligence. As natural language understanding improves, machines will learn from online data, apply that learning in real world tasks. In conclusion, in future of NLP's conclusion, human readable natural language processing is considered an AI complete problem because achieving full understanding of human language is as difficult as creating a machine with a general human level intelligence. It's solving NLP at this step requires machine to not only process words but also grasp content, meaning, and intent, which mirrors the core challenges of artificial intelligence, enabling computers to think and reason like humans. As AI advances, the future of NLP is closely connected to this development, allowing machines to learn from vast amount of online data and effectively apply that learning to perform real world tasks such as decision making, problem solving, and interacting naturally with the peoples. Then I am then I am concluding. Then modern NLP models leverage large-scale pre-trained transformation like BERT and GPT. That is, modern NLP model use large-scale pre-trained transformer architecture such as BERT and GPT. These models are trained on massive data set and learn contextual relationship between words, allowing them to understand language at a deeper level. Then pre-trained gives the model a strong foundation which can then be fine-tuned for specific tasks like question answering, translation, or test summarization. The next one is challenges including handling ambiguity, context, sarcasm, and understanding multiple languages. That is, despite the advances, and NLP still faces several challenges. Ambiguity means words or sentences can have multiple meaning depending on context, and context understanding means grasping the full meaning of text requires understanding the surrounding context, and sarcasm and irony meaning detecting the subtle tones or sarcastic remarks is difficult for machines. And multi-eagle understanding means handling multiple languages and dialect that remain complex, and especially for low resource languages. Then next is NLP application are widely used in chatbot, virtual assistant, search engines, and test summarization. That is NLP applications. NLP has many practical applications that impact uh, everyday technology, that is chatbots and virtual assistants. The chatbots and virtual assistants are enable human-like conversion. For example, Siri, Alexa. Next one is search engines. Search engines are improve relevance and accuracy of result, and last one is text summarization. In text summarization is automatically condenses large documents while retaining meaning. Thus applications show how NLP bridges human communication and machine understanding. Future of NLP. The future of NLP aims for human-like understanding, multi-legal support, and ethical AI, and integration with the multimodal data. That is, more human-like understanding means machines with better comprehend subtle meaning, emotions, and intent. Multilingual support means expanding robust understanding across diverse languages, and ethical AI means ensuring model as fair, unbiased, and safe for all users. And integration with the multimodal data means combining data, images, audio, and video for richer AI understanding and application. I am concluding. In recent years, natural language processing has experienced a transformative leap driven by the advent of large-scale pre-trained transformer models such as BERT, that is bidirectional encoder representation from transformers, and GPT. GPT is generative pre-trained transformers, and those models have significantly enhanced the machines. The models have significantly enhanced the machine's ability to understand, interpret, and generate human languages with a level of fluency and nuance that was previously unimaginable. Those advances have redefined the boundaries of what possible in NLP day, capturing contextual meaning through deep language representation, supporting transfer learning, where a model trained on a massive data set can be fine-tuned for specific tasks, and enabling few short and zero-shot learning, where model perform well even with limited task and specific data, but also challenges that still persist. Despite this remarkable process, several critical challenges continue to hinder NLP evolution. Already, we told ambiguity in language. The words and phrases can have multiple meaning depending on context. Example, bank as a financial constitution, where river bank is another. Then this ambiguation still requires deeper semantic understanding. The understanding nuance and sarcasm. The sarcastic or ironic language often depends on tone, cultural knowledge, or shared experience. Even advanced models struggle with subtleties that are intuitive to humans. Then contextual comprehension. Contextual comprehension means long-term context across multiple sentences or conversion is often lost for poorly maintained, and achieving human level understanding of dialogue flow remains a complex task. Then multilingual and low resource language support. That is while models like BERT, MBERT, and XLM support multiple languages, performance of often varies. And many languages, dialects, and linguistic structure remain understanding in training data, ethical and ethical and social concerns. NLP system can reflect or amplify social biases represent in training data, and issues is like misinformation generation, use privacy and algorithm fairness, and ongoing attention. The in real world impacts and applications of NLPs, chatbots are already told in introduction. We already told that chatbots and virtual assistant. Example Siri, Alexa, Google Assistant. It provides a 24 into 7 customer service and personal productivity tools. In search engine delivering more accurate, intent-aware search results to advanced query understanding. In text summarization and translation, make large volume of information more accessible across languages and reading level. In sentimental analysis, the main is sentimental analysis and opinion mining is helping business understand customer feedback, market trends, and social media sentiment. In healthcare flow and finance, we use automatically document analysis, report generation, and information retrieval with high accuracy. The future of NLP is human-like understanding, creating systems that can engage in deep, coherent conversation with real empathy and reason. Multilingual and cross-cultural AI is developing truly global models that can understand and interact in diverse linguistic and cultural contexts. In multimodal integration, we use combining NLP with vision, audio, and sensory data to enable richer, more intuitive AI system. For example, AI that can describe images or answer questions based on videos. Then ethical AI and responsible NLP, prioritizing fairness, transparency, and accountability in how NLP systems are built and deployed, and ensuring models do not propagate harmful biases or misinformation. And finally, the journey of NLP from rule-based system to data-driven deep learning and now to foundation model illustrate the incredible pace of progressing AI. While the current generation of NLP system has opened to the door to more natural, efficient, and human-like communication between people and machines, the ultimate goal remains building AI that not only processes language but truly understand it in all its complexity. With the continuous innovation and responsible development, NLP stand poised to reshape how we interact with technology. Thank you. Thank you all. Hello?
Yeah, thank you, ma'am. Dear participants, it's time for question answer session and feedback. So if you have any queries, you can ask to Turtha ma'am, or you can type in the chat box. So ma'am, there is a question in the chat box, that is, what is BERT? B-E-R.
Thank you all. Thank you.
Ma'am, there is a question in the chat box, that is, what is BERT? Will you explain in brief?
Hello.
Yes ma'am, can you hear me? Hello Turtha ma'am, can you hear me? Hello ma'am. I think she has some network problem. Hello Turtha ma'am. Hello ma'am, can you hear me? So let's wait for a few seconds. I think she has some network issues. Hello ma'am.
Hello. Hello. Can you hear me?
Yes ma'am, yes ma'am.
Okay.
Ma'am, can you please check the chat box? You have some questions there. So the first question was, what is BERT? Can you please explain it briefly? Hello ma'am. Hello ma'am. Okay, I think she has some network issue. Hello ma'am. Ma'am, you are not audible. Hello. Ma'am, you are not audible. Hello, Tirtha ma'am.
Hello.
Yes, ma'am. Yes, ma'am. So I think she has some network issue. So let's wind up now by giving a thanks to Tirtha.
Hello.
Yes, ma'am.
Can you hear me?
Yes, ma'am.
Can
Yes,
you hear
ma'am.
me?
Yes, yes. Now I can hear you.
Okay. Okay. This is the first thing. It is possible to apply NLP to wireless communication. Of course, it is possible and increasingly valuable to apply NLP in wireless communication, especially as especially in wireless systems become more intelligent and adaptive and user-centered. While NLP traditionally deals with NLP is traditional deals with the human language and its integration into wireless, and it domains into growing due to advancements in AI-driven communication systems, smart devices, and context-aware services. The wireless devices are these use voice-controlled system like routers, smart uh, smart antennas, mobile devices. Hello?
Yes, ma'am.
Okay.
Ma'am, there was one more question. That is, what is BERT? Will you explain in brief? What is BERT? B-E-R-T.
BERT is a bidirectional encoder representation for transformers. Actually, BERT is groundbreaking pre-trained model. It is a pre-trained model developed by Google AI and that significantly advanced the state of the art in NLP. It is based on the transformer architectures. Actually, it is based on transformer architectures and introduced bidirectional context modeling. Which allows him to understand the full context of word by looking at the word before and after it in a sentence. That is word. It is a bidirectional encoder representation from transformers. Pre-trained model means trained on massive corpora like Wikipedia and book corpus. Clear? Hello?
Okay, I hope it is clear for the participants. So is there any questions left? I think the questions are over. So thank you, ma'am. Thank you so much for your insightful and engaging session on natural language processing. And you introduced us the fundamentals of NLP. You explained how computers interact with human language, and we learned about its two major components. And your explanation on various techniques and methods in NLP, along with the practical sessions, made the topic clear and interesting. You summarized the future of NLP and its application also. So we truly appreciate your effort and time in delivering such a valuable session. We are grateful for your time and effort for spend this session with us today. I hope everyone found the session useful. So let's wind up the session. Thank you, Tirtha ma'am, for your effort and presence.
Thank you, ma'am. Thank you, Emil College, for this opportunity. Thank you.
Thank you. So a quick reminder for the participants, the session feedback form is in the chat box. Please fill it now as it is linked with your attendance. The feedback form is in your chat box. You can fill it and you can leave the meeting after that. And thank you all the participants. Dear participants, there's an announcement that tomorrow we'll start our sessions at 2 p.m. So we have two sessions from 2 p.m. to 3:30 and 3:30 to 5 o'clock. And 5 o'clock to 7:30, we have three sessions tomorrow. So we will start our sessions at 2 o'clock onwards. So make sure you join the class on time. And also we have a test tomorrow at 7 o'clock to 8 o'clock. So that's the test time. The details of test is given in your WhatsApp group. So please make sure that you went through the details. So I repeat again, you have three sessions tomorrow. Like we'll start from 2 o'clock and we'll end at 6:30. So from 6:30 to 7, we have a valedictory session. After that, we'll go straight to our test. It is conducting in between 7 o'clock to 8 o'clock. So it is a final assessment test for the FTP. It will be conducted on it is after the last session of tomorrow. And you will get the test link through the AICT ATAL portal. You can just go check the AICT ATAL portal and you will get the test link. You can do your test through the ATAL portal. And to attend the exam, you need minimum 80% of attendance. Only the participants who has 80% are eligible to attempt the exam. The attendance will be uploaded in the portal by tomorrow itself before the exam. So make sure you check your attendance and you can attend your exam. So in the assessment test, you need 70% of the score. Then only you will pass for the certificate. So make sure that you attended all the answers and make sure you got 70% to get the certificate. I hope it is clear. So tomorrow we'll start by 2 o'clock. So be ready for that time. Those who have completed filling their form can leave.